this here. So let's look at problems 1 through 8. Are there any questions on problem 1 through 8 or any of those that we want to look at? Or any of those that you have questions on or want to see worked? Are we good with 1 through 8? Because if we looked at problem number 1, it would be parentheses because it's not equal to. Then we'd have negative 256, comma, 100, and the 100 would have a bracket because it is equal to the 100. It is not equal to the 256. Well, if we look at problem 3, it says x is greater than or equal to negative 174. So the smallest number that we could have is, and the biggest number is, 174 would have a, infinity will always have a, yep, we can never include it. Okay. If there are no other questions on 1 through 8, let's look at 9 through 14. Any questions on 9 through 14? Anyone that we want to, or that y'all want to have looked at? 9. So we're talking about the interval of negative 24 to 87, where 87 is included. Well, I can't write this in set builder notation. I do need to rewrite it as an inequality. Two numbers, so x is in the middle. The smaller number is 24. The bigger number is 87. Now 24 is just less than because of the parenthesis, and then the bracket would be less than or equal to. So any questions on how we changed it from interval to inequality notation? So are we good with going from one of those two? Going from this to, because that's what we did on the first page, we just did it in the other direction. Now the set builder is we'd have the set of all real numbers x, or curly bracket x bar, because since we're talking about an interval, we're talking about all real numbers. The set of all real numbers such that what? Negative 24 is less than x. Because when we write it in set builder notation, we cannot have it in any, we have to have it in inequality notation. We cannot have it in interval notation. So the parentheses and brackets we cannot have. We need to write it as with our less than, greater than, less than or equal to, or greater than or equal to, and our x. Any other questions on 9 through 14? Any other ones that we want to look at? Which one? 10. The set of all integers, x is greater than or equal to 20. So when we start this off, so normally if I do our curly bracket x bar is saying what? The set of all real what? Numbers. Are we talking about all real numbers? No, we're talking about the set of all integers. So we're going to say x is an element of the z bar, which is our integer, such that what? Element. So we're saying x is an element of the integer such that x is since it was already in as written as an inequality, we didn't have to change it. I just cannot have it as a interval. Any other questions on this here? We won't have time for all of them. set of all natural numbers greater than 56. So the set of all real numbers x, well, that's what we would normally say, but natural numbers, what is our symbol for natural numbers? N with 2 bars. Such that, what? Greater than 56. So we would say what x is? Because we're saying x is an element of the natural numbers such that x is greater than 56. And it asks us to write it so that it is the set of all natural numbers greater than 56. So what's the inequality, or the interval? This is the interval notation, 6, infinity, yes? So how would I write that as an inequality? X is what? X is greater than 6 because we're talking about all the numbers greater than 6. So the set builder notation would be for all real numbers x such that x is Any other questions on this here? If we have time, we can come back to it. Any questions on 15 through 18? So we look at 15. The first thing we need to pick is a variable to eliminate. What variable can we eliminate out first? Y. Why would y be a good one? It's all the same. We have 5y in every single one. So it's a good one to pick. Now the eliminator equation really doesn't matter. I'm going to stick to the bottom one. So we have negative x minus 5y minus 5z is equal to 2. And our other equation is 4x minus 5y plus 4z equals 19. Now, since the y's values are already matched up, we can just go on and write them down. If they didn't, then we would have to make them be the same. But here, since they're already the same, we don't have to do anything to it. So we're wanting to eliminate y. So looking at the one on the left, so we have negative 5y and positive 5y. Would we add or subtract? We would add because the signs are opposite. Well, negative x plus x is 0. Negative 5y plus 5 is 0. Negative 5z plus negative z is negative 6z, because negative 5 minus 1 is going to be negative 6. We're making it into a bigger negative. And lastly, 2 plus negative 20 is negative 18. Right, I'm going to just go on and divide both sides by negative 6, because how many variables do we have? We just have one. Because if it ends up working out that I do have an equation with just one variable, we might as well solve for it. Any questions on how this worked out so far? And the other equation we're going to add again because the sign in front of y is opposite. 4x plus x is 0. Negative 5 plus 5 is 0. 4z minus 3 would be 3z. And 19 plus negative 20 would be negative 1. Now, since the other equation he gave me, 5x plus 3z equals negative 1, well, we know what the value of z is already. It is 3, yes? So at this point here, I can take 5x plus 3z, well, z is 3, and we can plug it in. Well, 3 times 3 is? And then what do? Solve for x by subtracting 9 from both sides. 5x equals -10. Divide both sides by 5. And we get x is equal to -2. Now we can pick any equation to use. X plus 5y minus z equals -20, I believe is one of them. I just grabbed it. It doesn't matter which one we use. We can use any of them. I just picked one. And we plug in our values. Well, x is -2 plus 5y minus z is 3 is equal to -20. We can combine our like terms because really we can just drop those parentheses and we get -3. So we have 5y minus 5 is equal to -20. Right, the first step in getting y by itself is to add 5 to both sides, which tells us 5y is equal to, and then y is equal to -3. So the answer for this here is -2, -3, and 3. How else could we have gone about solving this? Yeah, we can plug it into the calculator. We could have used the augmented matrices and found the answer to this here. Because the instructions for this part are here say what? Solve each matrix or system by what? Any method, yes? Any method. Yeah, any method. You can do it by any method. So you might also want to make sure that you know how to solve one of them by hand. Because if it specifies to do it by hand, you need to do it by hand. If it says any method, we can use the calculator. There's nothing wrong with that. So any other questions on this here? Are you good with systems? Especially if we can use a calculator for it? Yes? If not, I would go back and look back at the video of how we plug those in. Using the augmented matrix, putting it as a matrix, and then getting our RREF. Okay. Any questions on 19 through 24? 19 through 24. Any one of these here in particular that y'all want to look at? When we write an augmented matrix, we need all the variables on one side and all the constant terms, the numbers without a variable, on the other. So when we write an augmented matrix, the first thing we want is the variables on one side and all the numbers on the other. One side the equal sign, numbers on the other side. Here we do have it because the constant terms 2, 15, and 20 are all on the same side of the equal sign, and there are no variables with it. The next part is what the variables had to be in what? Alphabetical order. We have to go x, y, z. So when we looked at the top equation, 6x is first, so our first number would be, since there's not a y, it would be 0, and then z would be, and then our con. Now how about the next equation? So even though it does have y written first, which variable has to go first is x. And the number in front of x is -7. Then 1 for y, 4 for z, and 15. Now I could have rewritten the middle equation as -7 plus y plus 4z equals 15, but it's still the exact same thing. because we still need the number in front of x going first, the number in front of y going second, z third, and then our constant terms fourth. And finally, our last equation would be -1, 3, and 20. And that would be the augmented matrix. And if we were solving for this here, then we would plug this into the calculator if we wanted to do it that way. Plug it in for matrix A, and then use our REF, matrix A, and it would give us the solution. Now, what are the dimensions of this here? 3 rows, 4 columns. So it is a 3 by 4. Any other questions on this? So write the augmented matrix. We did that, yes? And state the dimensions. Does it ask for anything else? So we're done. So here it's just asking for the augmented matrix and the dimensions. It's not asking for the answers. But if we were doing a system, then we would write it as an augmented matrix and then use REF to solve. Any other questions on this here? We good with this here? Yes, sir. Yes, ma'am. 21? Yes. So we look at 21. XY number, yes? So it's all set up exactly as we need. So what would the numbers be for the augmented matrix? 6, -3, 7. And this is a 2 by 3. Now we don't need to put zeros in for Z because it doesn't have a Z. How many times does a variable need to show up for it to be included? Once. So if one of the equations has Z and the others two don't, we need to include it in all 3. It might show up as zeros, but we do need to include it. So if a variable shows up in one of the 2 or 3 equations, it needs to show up in all 3 by putting in a 0. Now for this here, since Z didn't show up in either one, it's not included. Any questions on this here? Questions on 25 through 31. Okay. Now, as I said in the lessons, and I'll write them up here on the screen eventually, but these here I do have up on the whiteboard. The y equals, because when we covered this, we really dealt heavily with these here. Because we talked about a horizontal translation moving left and right, we really talked about the y equals f of x minus h, and we plugged in whatever movement to the left and right we had for h. The same thing with vertical translations, horizontal stretch, shrink, and reflection across the x and y axis. So when we look at this here, okay. So here, 26, we talk about it being translated right. 4, right is our horizontal. So we'll say h of x is equal to f of x minus. How far are we going? 4 to the, and right is positive, yes? So the value of h is positive 4. So I'll plug that in and we get f of minus 4. Because again, h is positive, but because of how it's set up, it's going to be minus 4. If it had been to the left 4, it would have been x minus negative 4. The negative and negative would give us our positive. Okay? Do I have f of x anymore? Because that's what we started out with, yes? Well, no, I have f of x minus 4. So everywhere in this function where there's an x, it needs to be replaced with an x minus 4. So what we'll have is 2 parentheses x minus 4 minus 1. There we go. Now we do have a number in front of the parentheses we do need to distribute. So we would distribute the 2. Well, 2 times x is minus 8 minus 1. Add our like terms, which would give us 2x minus 9. So we have translated it right 4 units, yes? So really with that left and right, that horizontal, I'm sticking with that f of x minus h. And I simplified it. Now where are we moving next? So g of x, our next function would be our h of x plus k. Vertical translations up and down is our f of x plus k. Or here it would be g of x. Now it says up 3. Up is positive and our movement is 3. So we would say h of x plus 3. Now what is h of x? So it's the absolute value of 2x minus 9. And then we'd have plus 3. Since there's nothing outside the parentheses, we'll just drop it. And that is it. Now I don't have those written up on the smartboard, but I will take a picture of those and include it in Google Classroom once this is done so that you have those. I would have those written down somewhere on my note sheet because as you all can see here, it's really just plugging in the information into those. Because once we plug the information in, so like the x minus 4, we plug it back into the function or plug it into the function or plug the function where it's supposed to be, simplify, and then move on to the next one. Is there another one of these that we want to look at? Any other questions on 25 through 31? Reflection across the x-axis and then translate it 4 units up. So our reflection across the x-axis is going to be our negative f of x. Because the reflection across the x-axis is our y equals negative f of x. Well, I still have the f of x. I didn't change anything inside the parentheses, so we can go on and replace it. So we'd have negative parentheses. Absolute value of 4x minus 3 plus 2. So we can't quite drop the parentheses, but we can distribute the negative. The negative sign will not go inside the parentheses or inside the absolute values. It stays on the outside. But our negative and positive 2 is going to make it negative 2. So after the reflection across the x-axis, done, we now have negative absolute value of 4x minus 3 minus 2. Any questions about the reflection across the x-axis? Now the other movement that we have is up 4. We're moving it 4 up. Well, our vertical translation is our y equals f of x plus k. So here we would just say g of x, because that's the function we're using, plus 4, because we're going up 4. Up is positive, so we're adding 4 to the function. So what is our function g of x? Well, negative absolute value of 4x minus 3 minus 2 plus 4. Now I don't have anything outside those parentheses, nothing's affecting it, so I can just drop it. Negative absolute value of 4x minus 3 minus 2 plus. Negative 2 plus 4 is plus 2. And that is it. Any questions on this here? All right. If we have more questions on these here, we can come back to 29 and 30. I want to get to the rest of, and 31. I'll get to the rest of them here in a little bit. I know that the problem numbers here at this point differ a little bit from what I have on the screen. This is what I had up there, or previously before I added 30 and 31. So the numbers are off a little bit here, but that's fine. Any questions on these two here? So we're good with these two here. We don't need to see how 30 or 31 is worked out. So are all the matrices the exact same dimensions? Yes. So we add and subtract the corresponding elements.
Yeah, different numbers. Your 31 is my 33.
And I just said it 2 minutes ago.
Oh.
Because I added 30 and 31. So this here is off because it's from last year. I just added the 2 in. But so we add and subtract the like elements, yes? Well, we can do it one at a time, or really if we wanted to, again, we can type this on the calculator. Set it as A, B, and C, and tell it A minus B plus C, hit enter, and it'll do it for us. Now, the way we did it in class, we might take the first two and then figure out what that is and then add the third one in. But really, I'm taking 2 and subtracting what from it? 1, and then I'm going to add 3. Because I can do that as one step, as long as there is no scalar in front of any of them. If there are, we'll have to apply the scalar 2. So I can do 2 minus 1 plus 3. And then we'll have 7 minus 4 plus 8. Then we'll have 9 minus 16 plus 7, and 8 minus 27 plus 2. Now, we could do the first two if it's better, if you find it more helpful to subtract the first two and then add the third one in. Do it that way. Do it in 2 steps. But here, 2 minus 1 is 1 plus 3 is 4. 7 minus 4 is 3 plus 8 is 11. 9 minus 16 is plus 7 is 8 minus 27 is negative 19. Plus 2 is, and that is it. Any other questions on those there? Does that make sense? We good with these two here? Any questions on these two? Number 35 was? Not possible. Because the dimensions are not the exact same. We good with 34 and 35? With these two here? 37? Okay, we can do this by hand, or we could actually type this straight into the calculator, because we can do negative 2/3 times matrix A plus 3/5 times matrix B, hit enter, and it's done. Now, if we do this by hand, negative 2/3 will multiply through. Well, negative 2/3 times 9. Negative 6, yes. Negative 2/3 times 8, which would be positive 16 over 3. Negative 2/3 times 15 would be negative 10. And negative 2/3 times 21 is negative 14. So really what we're doing is we're just multiplying each of those elements by that number out front. So are we good with this here? Yes. Now the next one is we're going to multiply all of these here by 3/5. So here we would have 21/5. Here, well, it's going to be over 5. 18 times 3, 18 and 18 is 36/54. 3/5 times negative 21 is going to be negative 63 over 5. And lastly, we would have 6 over 5. 3/5 times 2 would be 6/5. Any questions on how we got to this point here? Now at this point here, we would combine our like elements, so negative 6 plus 21 over 5. 16/3 plus 54/5. Negative 10 plus negative 63/5. And lastly, negative 14 plus 6/5. Now at this point here, if we really want to add and subtract these numbers here, we need the denominators to be the same. It's going to be a lot easier, even if you don't do the whole thing out, just do each one individually in a calculator. It's going to be a lot faster and a lot easier. Because trying to figure out how to get these two denominators to be the same is a little tricky. As we would end up with fifths, but it would be negative 9/5. And then I believe this is 15. 222, 2 to 42. What? 5 and so even if you did this one all out by hand, it's going to be a little bit easier in the end to go on and just use a calculator to add and subtract those fractions. You could have also used the graphing calculator and typed it in from the get-go. And that would be even easier because it would just, Well, you'd define matrix A as 9, negative 8, 15, 21. Define matrix B as 7, 18, negative 21, 2. Because I can define this as A, this as B, and say negative 2/3 matrix A plus 3/5 matrix B and hit enter, and it would actually solve this. Any other questions on this one here? Are we good with this here? Yes? Any questions on 38, 39, or 40? Now, did they give us the y-intercept? Well, no, and they didn't give us the slope either. But our slope is y2 minus y1 over x1. What are our two y values for the points that are given? 90 and 40, so we can say 90 minus 40 over 40 minus 15. Since we chose 90 to go first, its x value has to go first also. Now, we could type this into a calculator at this point, or we can do it by hand. 90 minus 40 is 15. 40 minus 15 is 25, so the slope is 2. Now again, we already said that they did not give us the y-intercept. So I can't just jump to the equation y equals mx plus b. I have to use our point slope form first. Y minus y1 equals m times x minus x1. Now they told us the slope. Indirectly, we ended up having to find it. And the slope is 2. Now what point do we want to use? Mm-hmm. 40 minus 15. Now, it really doesn't matter which point we use, because if we use 15 comma 40 or 40 comma 90, we will get the exact same equation. Now we just need to get y by itself, y minus 40. We'll distribute the 2. 2 times x is 2x. And 2 times negative 15 is negative 30. Then what would we do next? We add 40 to both sides because we do want to get y by itself. Negative 40 plus 40 is 0, so y is equal to 2x plus 10. Any questions about how we found the equation of the line? Now the next thing it does ask us is to describe the slope or interpret the slope. Well, the slope is telling us for every minute in UTE of minute of practice, what happens? 2 pitches are thrown. And that's all we'd have to say for the slope, describing the slope. Because we're just trying to tell us, or write out what the slope is telling us. Any other questions on 28, 29, or 38, 39, or 40? 38, 39, and 40. Are we good with 38, 39, and 40? Yes. Are there any other questions on any other part of the review since we do have some time? 30? Number 30 here? 30. And again, with this here, with any of these translations or tessellations, let's just start at the top and go down. Horizontal translation of 4. So we're saying that we want f is equal to f of x minus, well, how far are we moving? 4 units to the left. So that would be negative 4. So we would say, start off with just saying g of x is equal to f of x minus negative 4. Well, negative and negative is the same as positive. So we start off with f of x is equal to 2 times the absolute value of x minus 3, yes? Do I have f of x anymore? No, we have f of x plus 4, yes? So that means this x here has to be replaced with x plus 4. So we're going to have 2 absolute value, parentheses x plus 4, minus 3. Well, we can drop the parentheses, which would just be x plus 4 minus 3. 4 minus 3 is positive 1. So we did the horizontal translation 4 units to the left, yes? What is the next thing it says? Vertical shrink of 1/3. So I'll just call it h of x. So our vertical shrink, if we're looking at that list, vertical stretch or shrink is a times f of x, a times the function, yes? So what's our vertical stretch and shrink? 1/3. So we'd say 1/3 times g of x. So if y'all are wanting to pay attention to this here, go on and stay and do that. Again, your test is tomorrow. All of your homework is due at the end of the day tomorrow. Okay. So as we look at this here, so 1/3 g of x is our vertical stretch and shrink, yes? Well, what is g of x? It's just 2 times the absolute value of x plus 1, yes? Or not 2. It should be 1/3 times, in parentheses, 2 times the absolute value of x plus 1, because that's our function, yes? And then we need to distribute the 1/3, and really we're just multiplying it by the 2 because the 1/3 will not go inside the parentheses or inside the absolute values. So 1/3 times 2 is 2/3 times the absolute value of x plus 1. So we did the first 2, we're only missing 1, yes? The horizontal stretch of 4, yes? Now I'll just call it m of x because it really doesn't matter what we call the function. But with horizontal stretch and shrink, we're talking about y is equal to f of a times x, because that's our horizontal stretch and shrink. So we're talking about g of our a is how much we stretch or shrink it, and how much was the factor? 4. So what do we plug in? Not 4, but because remember, with horizontal stretch or shrink, we have to flip it. Horizontal stretch and shrink is we have to flip it. Now, since, I don't know why I said g of x, it should be h of x. I keep wanting to do that because because the one we're talking about is this one down here, h of x. The h of x, g of x, that's just a lettering to keep track of which function we're using. That's the only real key to it, okay? So what we're saying is that I'm going to plug 1/4 x into this function here wherever there appears an x. I'm replacing it. So we would have 2/3 absolute value of 1/4 x plus 1. And that's it. That is all we have to do for this here. But if you notice, one of the big things is with all of those there, even though there's more than one of them, whichever one we're doing, we apply it one at a time. Don't try to do more than one of these transformations at once. Just do them one at a time, and really, those there are going to help. All right, guys, your test.